Last class we talked about the difference between a single variable equation, where there's only one type of letter, and a literal equation, where there are two types of letters. We did a really quick example about how to solve these kinds of equations for y, depending on what you had, but we're going to go into more detail about solving equations for y. So we're going to be working with our literal equations today. We got to make sure we have some definitions ironed out before we get started. So if we're talking about a variable term, we're talking about the piece of the equation with the letter. So the term or the piece of the equation that has a letter on it. So for example, the term 5y or negative 3x are considered variable terms because they have a letter attached to them. A constant term is a good old-fashioned number. For example, if you have, let's say, negative 2 or like 100, those are considered to be good old-fashioned numbers. Now, the word equivalent has the beginning sign of equal. So when we're talking about an equivalent equation, we're talking about the same equation written in a new way, written in a different way. And that's our goal when we're solving equations for y, is that we're going to write an equivalent equation. We haven't changed any of the values. We're just going to rewrite it in a different way. The steps for solving for y are below. If you have a highlighter or something like that, I would highlight these steps as we go through them because these are super important to know for today. So the first step is that we need to draw the line down the center of the equal sign, and then we're going to locate the variable. Locate the variable that we're solving for. The next step is to add or subtract these terms, which is kind of like the drag and drop, to move terms to the correct side. Remember to use those inverse operations. If it crosses the line, we have to change the sign. That's still a thing. We're going to combine like terms if needed. We won't need that as much, but it's a possibility. And then we're going to divide by the coefficient of y and reduce all of our fractions. Because when we divide by the coefficient of y, we're probably going to end up with two different division problems. We're going to have to reduce both of those. For example, let's say we have this training wheels problem that I solved mostly for you, but we're going to annotate it. We have 3x plus 4y equal to 12. We want to solve this equation for y. That's the letter we're trying to isolate or get by itself. So in the first step, we took the 3x and we're going to move it across the center line to the other side. But when we cross the line, what do we have to do? Yes, we have to change the sign. So that should be a negative 3x. Now, if you notice, I did not combine these two things together. Why? These are not like terms. Negative 3x and positive 12 are not like terms, so I cannot combine them together. Oops, I meant to erase all that. Okay, the next step, like it says, is to combine like terms if needed. We didn't need to. And we divide by the coefficient of y. The coefficient of y is 4. But there are two pieces on the right side, this piece and this piece, so I have to actually do two division problems. We're going to divide by 4 to every term on that side. And then we just play reduce the fractions. We would get y equal to negative 3/4x plus 3. 12 divided by 4 is positive 3. And we have our solution. That's the solve for y version of this equation. The beginning and the end are equivalent. They're just written in different forms. So let's try one together. Okay, we're still trying to solve for y. So let's highlight our y. That's what we're trying to get unearthed or get by itself. So we have to start moving pieces around. This negative 2x does not have a y on it, so we're going to move it to the other side. But when I cross the line, I'm going to have to change the sign. So now it's a positive 2x. The 18 gets to float down because I didn't do anything different with it. So now I have plus 18 behind it. Can I combine these together? Absolutely not. Those are not like terms, so I'm not going to add them together. I'm going to leave them just written as they are, as 2x next to a positive 18. The coefficient of y here, what I'm still trying to get rid of, is 6. So I'm going to divide every single term, all of them, by 6. I would isolate my y. I would get my y all the way by itself, which is awesome. That's what we want. And then I just reduce those fractions. 2 divided by 6 is 1/3 x. Yes, leave it as a fraction. If your answer comes out to a fraction, leave it as a fraction. Then we do 18 divided by 6. That would be 3. Our equation has been solved for y. Remember, you cannot combine these two things together because they are not like terms. That's such an important moment right there. Do not combine those things together because they are not like terms. That's about as complicated as it gets, folks. So we're just going to jump into some practice problems. On the other side of your notes here, we're going to solve the following equations for the indicated variable. The first one says solve for y, so we have the same kind of question. We'll do this last one together, and then I'll send you off on your own to do some work. We draw our line down the center of our equal sign so we can balance it out. And we realize that that 4x term needs to go to the other side. So I'm going to circle it. I'm going to drag it to the other side. Cross the line, change the sign. Everything else gets to come down, so I'm going to have 3y equal to negative 4x, and then that positive 9 drops down. I'm still trying to get the y by itself, so I'm going to divide away the 3 that's in front of it. But I have to divide that to every single piece. Therefore, I'd be left with y equal to, yay, it's by itself, I'm happy. Negative 4 divided by 3 is negative 4/3. You'd get negative 1.33 repeated. We're just going to leave that as a fraction of negative 4/3. And then 9 divided by 3 is 3. We double check to make sure we still have an x term, a y term, and a constant, because we started off with an x term, a y term, and a constant. And we're happy. All right, guys, let's have you try number 2. Pause the video, give it a shot. So again, I draw my line down the center of the equal sign, and I identify the variable we're solving for. We're solving for y. We're going to get that by itself. So we take the 20x, we're going to move it away by cross the line, change the sign. Everything else gets to drop down to the next line of the equation. You have your positive 5y equal to negative 20x, and then the positive 15. We are still looking to get y by itself, so we're going to divide away the coefficient of y to every term left in the equation. We would have y equal to negative 20 divided by 5 is negative 4x, and 15 divided by 5 is positive 3. I have x term, y term, constant, because I started with an x term, a y term, and a constant. I'm happy. Your turn on number 3 and 4. Again, pause the video, see if you can get this one right. For both of these equations, you're going to take the x term across the center line and change its sign so that then we can divide by the number in front of the y and reduce our fractions to isolate the y. Once we've done both of them, remember we're always going to do a really quick check to make sure that we still have an x term, a y term, and a constant, because we started with an x term, a y term, and a constant. X term, y term, constant, x term, y term, constant. Awesome. Now if you look at number 5 is the kind of multiple choice question you might see, say, on a fill-in-the-blank test or a STAR test, and it says, which of the following is equivalent to? Now we highlight the word equivalent because that's a key word here in our equation. We're trying to find something that's equivalent to this expression, to this equation. But if you notice, all of the answer choices are solved for y, which means that we should probably solve this equation for y so that we can see which one it's equivalent to. That's how we make the decision of how to solve this equation. We draw a line down the center of the equal sign, and we're going to solve for y. That means the first term, that 3x term, needs to bloop cross the equal sign. We'd be left with positive 4y equal to that opposite, negative 3x, and a positive 6. Remember, we're still looking to isolate the y, so we're going to divide everything, bloop, 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 by 4, so that we have y equal to negative 3 divided by 4, which is negative 3/4 x, and 6 divided by 4, which reduces to 3 over 2. That's what we think the answer is, and if you notice, that matches answer choice D. We have written an equivalent or same equation just in a different form. Now the equations over here are extra practice. I'm just going to show the work on these and I'm not really going to explain them because I think we had enough explanation so far, but if you need a few more examples to look at, we'll finish out the video there. See y'all next class.